So this is one of the problems you're going to have to face tomorrow. So I plotted the points. Of course, I just for the time for a little time saving, just plotted the points with Sketchpad just to save myself some time and save some recording time. So it looks to me like this is going to be a trapezoid, but again, I'm not going to trust it until I do my computation. So I put the points here. You can see that this is, of course, a horizontal line. So the horizontal line, the length is just the difference in the x coordinates. So that length AD, AB rather, is 8 units. Okay, that's what I asked for down here later, but uh, it's easiest to compute right now. Okay, so that's 8. Okay, now we're going to do the slopes. Okay, the slope of AG. So the slope of AD is going to be 9 minus a negative 1 over negative 6 minus a negative 2. So it's going to be 9 minus a negative 1, which is 10 over negative 6 minus a negative 2, which is negative 4. So I'm going to get negative 5 halves for that slope of AD. Negative 5 halves, always reduce it. The slope of CB, okay, the slope of CB is going to be the difference in the y's, which is 9 minus 4, which is 5, over the differences in the x, which is 2, 2 minus 4, which is negative 2, okay? So that's 5 over negative 2, which is the same, so negative 5 over 2. So I know that these two have the same slope. I'm going to mark them off, which is telling me that my suspicion is that this was a trapezoid, which at this point it is. I don't think I'm going to find these slopes to be equal, okay, but let's do the computation anyway, okay? Get rid of this a little bit. Okay, so DC, the slope of DC is, of course, 4 minus a negative 1, so that's 4 plus 1 over 4 minus a negative 2, which is 4 plus 2, so that looks like 5/7 on the slope there, 5/7, okay? And the slope of AB, well, this is a horizontal line, and a horizontal line, as you'll see computing it, but the slope, there is no slope, it's a zero slope. So the best I can compare here is that I have these two have the same slope, so AD and BC are parallel. I'm going to make my measurements as to my lengths here because I have a suspicion that this might be a isosceles trapezoid, okay? So let's compute our distances here, okay? So AB I already have. Let me do DC since that's the one which I suspect might be equal. So I'm going to do that one now. So DC distance, don't forget distance formula, the square root of x1 minus x2 quantity squared plus y1 minus y2 quantity squared. Y1 minus Y2 quantity squared, okay? All right, so I'm going to just put that down, but I'm going to erase it because you need to remember it, okay? So my distance for DC is going to be, okay, 4 minus a negative 2, so it's 4 plus 2, the quantity squared, plus Y's is 4 plus 1, quantity squared. Okay, so that's going to be the square root of 6 squared is 36 plus 25. So that is going to be equal to, what, root 61? And I can leave it at root 61. It's certainly not equal to 8. If it were root 64, it would be equal to 8. So I'm concluding that at best this is a trapezoid, not an isosceles trapezoid. Let's just, for good measure, go and find these other lengths, which we're going to have to do at any rate. Okay, so AD, the distance for AD is going to be, okay, negative 6 minus a negative 2, which is negative 6 plus 2 squared, plus 9 minus -1 is 9 plus 1, the quantity squared. So I'm going to get -6 and 2 is -4. -4 squared is 16 plus 10 squared, which is 100. So I'm going to call this the square root of 116, which I'll just leave it at that. That's fine. And CB, lastly, is going to be my distance. CB is going to equal the differences of the x's, which is 4 minus 2, the quantity squared, okay, and then plus the differences in the y, which is 9 minus 4, the quantity squared. So that's going to be 2 squared plus 5 squared, which looks like 29. So that's root 29. So my conclusion as to what type of quadrilateral this is that this is a trapezoid. This is a trapezoid, okay? And that's the best I can conclude because it has but one set of parallel sides. So that's what you're going to have to do with these exercises. Compute the slopes. And, of course, if we have two sets of equal slopes, then we've got a parallelogram. If we have a parallelogram, then we've got to determine whether it's a rectangle, rhombus, or a square. And so we could use the distances there to make that measurement and comparison and make our conclusion. Again, I suspect we're going to give you one of each type of figure, okay? So slopes will determine whether you have parallels or not. Slopes will also determine whether you have perpendicular, which is a right angle. So in other words, I had my one slope is -5/2 as CB. If DC ended up being 2/5, then that would establish a perpendicular condition, which would be a right angle, which would kind of lend itself to this being either a rectangle or a square, okay? So that's the process you're going to go through tomorrow. A little lengthy at times, but you know, just fine-tune your skills with your distance formula and your slope measurements, okay? And remember, in terms of our comparison, we didn't need to get a decimal value. You can just leave them as a radical, and obviously you'll see if you have equal lengths, whether you take the root of those or not, okay? So, so that'll do it, okay? And good luck with these exercises tomorrow.